So this is our chapter 4 study guide. So question number 1, finish the definitions. A to the S times A to the T. So what you want to do is to add your exponents. So this is A to the S plus T. The second one, 1 to the S, that is just 1. So it doesn't matter what number this S would be, it's just always going to be 1. A to the S to the T power, so this one you want to multiply. So this is A to the S times T. A to the negative S, the negative just tells you that it's in the wrong spot, so this is 1 to the A to the S. So the negative says move this from the top to the denominator. AB to the S power, you can distribute the S. So this is A to the S, B to the S. A to the 0 power, so any number and letter to the 0 power is just going to be 1. So it doesn't matter what A is. If A to the U equals A to the V, then U equals V, if and only if the bases are the same. So these A's would have to be the same thing. Okay. So this would not work if this said A to the U equals B to the V. Those would not work because the A's wouldn't match. So they have to be the same letter or the same number. Okay, number 2, find the vertical, horizontal, or oblique. It says and or oblique asymptotes if they exist. Okay, so we're going to separate this into 3 separate problems. So case number 1, the first thing you want to do is factor the denominator right here. So if I would factor the denominator, the top is going to stay the same for now. So on the denominator, we are thinking what will multiply to 2 and subtract to give me 1? Well, the only thing that times 2 is 2 and 1. So I know I'm going to have a 2 and I know I have a 1. The minus at the end tells me the signs are different, and this one in the front goes with the bigger number. So the 2 gets the minus, the 1 gets the plus. Okay, so your vertical asymptotes, you set both of these pieces equal to 0. So x minus 2 equals 0. So x equals 2, and then x plus 1 equals 0, so x would equal negative 1. So your 2 vertical asymptotes would be 2 and negative 1. All right, so for horizontal and oblique asymptotes, you want to look at the 2 degrees and the front. So if I look here, this is a 1 and that is a 2. There is a rule that says that if the numerator is 1 less than the denominator degree, then you automatically have a horizontal asymptote at y equals 0. So that is just a rule. There's really no work to show other than you have to know the rule. Okay, the next one, f of x equals 3 to the x minus 2 minus x squared divided by x to the third minus x squared plus 1. So I'm going to just focus on the horizontal and oblique on this one. Look at your degrees. If the top degree, which is 4, is 1 more than the bottom, that tells you that we have an oblique asymptote. and it's found using long division. Okay, so we have x to the third minus x squared plus 1 on the outside. On the inside, we'll put x to the fourth. I'm going to put zeros in as placeholders. Okay, you can fill out the other placeholders if you need to. All right, so I look at what I need. I need a 3, and I need one more x, so this is going to be a 3x on the top. So 3x times x to the third is 3x to the fourth. 3x times negative x squared, that would be negative 3x to the third. 3x times 1 would just be positive 3x. So then the next thing you want to do is you want to go through and change your signs. So that will be a minus, that will turn plus, that will turn a minus. And then you want to subtract going up and down. So 0 plus 3, that's going to be 3x to the third minus x squared minus 3x. And then you can add on your plus 0 at the end. So look here, I know I need a 3. I don't need any more x's because I have the number that I need. So 3 times x to the third is 3x to the third. 3 times negative x, that would be negative 3x squared. 3 times 1 would be a positive 3. And then I need to go through and change my signs here. So that will go negative, positive, negative, add going down. So 3 minus 1 would be a 2x squared minus 3x minus 3. Okay, now look at your exponents. This is 2 and this is a 3. This is less than this. So all of this is the remainder. And your oblique would be the equation y equals 3x plus 3. So that would be your answer for your oblique asymptote. On the test, they will not make you use long division to find the oblique asymptote. They only have you find the actual asymptote on the labs, so you can breathe a little bit easy on that. The only thing it's going to ask you is if it is oblique or horizontal. Okay, but you do have to know everything about it. All right, and the last one here, negative x minus 4 divided by x. So I would have a vertical asymptote at x equals 0 because I set my denominator equal to 0. Look at your degrees. I have 1 on the top and 1 on the denominator. When they are the same, you are picking off the coefficients in the front. So I know that this is a negative 1 and this is a 1. I pick off those coefficients. So I have a horizontal at y equals, and I look in the front, negative 1 divided by 1 would be negative 1. Okay, now if you look into your book on page 355, there is a blue box at the bottom that tells you finding horizontal and oblique asymptotes of a rational function, and it goes through all of the different scenarios. You need to have this memorized. So if n is less than m, the degree of the numerator is less than the degree of the denominator, you will have what they call a proper rational function. It just means it's horizontal at y equals 0. Okay? If n is less than or equal to m, so the degree of the numerator is greater or equal to the degree of the denominator, then r is proper and long division is used. Okay, so this is the more common. So if they're equal, then you pick off the coefficients in the front and it's horizontal. If n is equal to m plus 1, so the degree of the numerator is 1 more than the degree of the denominator, then you get oblique and you have to do long division. If it's 2 or more degrees, the numerator is 2 or more greater than the denominator, then you have neither. So neither horizontal nor an oblique. You need to memorize this box, and that box is in the 5th edition of the book, page 355. So make sure you memorize that box. If you don't know that box, you will not do well on this test. There are several questions on the test that you have to have this memorized, and if you don't, you will not do well. So trust me, I mean, there is probably at least 5 questions that deal with that box. So page 355, blue box, you have to have that memorized. Okay, question number 3. She loves this question. You will find this again on the final. Just something of this sort of question type is definitely a final material also. So what is the domain of the following rational function? So you have to set the denominator equal to 0. Before you would do that, I would simplify. So on the numerator, I can take out an x. So I'm just factoring here. So I get x plus 2. On the denominator, let's try to factor this thing. So we'll put our x's in the front. We need to figure out what times to 8 and adds to 6. So 4 times 2 is 8. 4 plus 2 is 6. So I know I'm going to use a 4 and a 2. This tells me the signs are the same. Both signs are going to be positive. So if I look, these cancel. So what we have here is we have a whole at y equals, well, let's go through this real quick. So you would set that equal to 0, and when you minus your 2, you're going to get negative 2. So the whole is at negative 2. Okay. Now, since there is a hole in your graph right there, it will be in the domain also. So your domain is you set both of those pieces equal to 0 on the denominator, including the one you canceled out. Because it's a hole, you have to exclude it. So this would be negative 4. That would be negative 2. So this will be all real number. Wow, I can't spell today. Let's try this again. Okay, all real numbers except x does not equal negative 4 and x does not equal negative 2. Okay, number 4, find the domain of the rational function of the graph below. So you want to list everything on the x's, so I kind of picture smashing the graphic against the x-axis. So we would start here at negative infinity, and the graph would keep going until we hit this vertical asymptote, and that is at 1. And the 1 is not included because the graph will get close to these lines, and even though it kind of looks like it touches them, it never will. So union will start back with the 1 to infinity. So all of these will get parentheses. Okay, second picture of the graph, you can see I have a vertical asymptote right there going through 2. So this is fairly similar to the other one. So we will start at negative infinity. The graph continues up until 2. And then it will pick back up at 2 and continue on to infinity. Okay, number 5, this is that box pretty much listed out. You have to have this memorized. And not just memorized, you need to be able to apply it also. So if the degree of the numerator is less than the degree of the denominator, then we have, and they want to know what type of asymptote. So that would be horizontal. And this is just a definition. There's no work for it. So this is horizontal at y equals 0. If the degree of the numerator equals the degree of the denominator, then we have horizontal at, and this one I'll write it out kind of the way the book has it listed. So it was a to the n over a, not a, b to the m. So you pick off the coefficients in the front from the numerator and the denominator. You pick off the first coefficients. And we did that on that first page. If the degree of the numerator is 1 more than the degree of the denominator, then we have an oblique asymptote. And to find that, you have to do long division. If the degree of the numerator is 2 or more greater than the degree of the denominator, then we have neither oblique nor horizontal. So you don't have either one. Okay, question number 6. Which of the following below would have this graph? So this is how the questions come. If you don't have that blue box memorized, which we just did on that last question, it makes it really hard, and this is how you'll miss multiple questions. You don't get a graphing calculator. So you can't just go through and type in the answer choices in the graphing calculator and match up the pictures, because you're not given that luxury. So you have to actually know the rules here. All right, so I think the least amount of work to start with to maybe try to eliminate stuff is to look at the degrees and figure out where is my horizontal asymptote. I would work with that first, so then you don't have to do quite as much work to work with the vertical. So it might be a little bit hard to read here, but right here is the horizontal asymptote. It's at -3. So since it's at -3, I know the top and the bottom degrees have to be the same, and I need to pick off the coefficient from the front. So looking at A, picking off, I know these are the same, so we're good. Pick off the coefficients at the front. This would have horizontal at 1/3. Well, that's at -3. That's not the same. So it's not going to be A. Okay, B, pick off the coefficients. Horizontal at -3. That's a possibility. C, these are the same. The degrees are both 1. Pick off the coefficients off the front. So I have 3 and 1, -3 over 1. That's a possibility. So I know right now I'm looking between B and C. So then you want to work with your vertical asymptotes, and you also look at your graph right here. You have a hole in the graph. So that tells me that something is going to need to cancel out. So we're going to go ahead and factor this right here. So looking at the denominator, we'll start with it first because it looks the easiest. What's the only thing that times to 3 and adds to 4? It has to be 3 and 1. Okay, I'm going to need a little bit more space to do this on the top, so I'm going to come up to the top of my worksheet. So if I look, I can take out a -3 out of all of these positions. So I'm going to factor out a -3. So that gives me x squared. That's good. -21 divided by 3. -3 would be a +7x. Okay, negative 36 divided by negative 3 would be a positive 12. Okay, so then we need to factor this. So I need to figure out what times to 12, and we'll add to 7. Okay, so I need to figure out, I got that negative 3 in the front. I need to figure out what times to 12 and adds to 7. Well, that would be a 3 and a 4. And since the signs are all plus, I know these are both going to be pluses. So I have a negative 3 in the front, and then I have an x plus 3 and an x plus 4. Okay, so if you look, the x plus 3's cancel. That means there's a hole in the graph at negative 3. So if I look at negative 3 on the x's, I see there is a hole in the graph. That's good news. Set the denominator equal to 0, so x plus 1 equals 0. So I get x equals negative 1. That's my vertical asymptote. And I look at negative 1, and I have it right there, so I know B is my answer. And I know my answer is not C because nothing cancels out, so I don't have a hole in the graph. So if that hole was not there, then your answer probably would be C. Okay, let's look at question number 6. Again, I would start by looking at your horizontal or your oblique asymptotes first. So if I look here, the degrees are the same, so I'm picking off the coefficients on the front. So this would be a horizontal at 1/4. Well, there is no horizontal in this picture at all, so I know A is not an answer choice. I look here, the degree on the numerator is 1 more than the degree of the bottom, the denominator, so that automatic by definition is a horizontal at 0. Well, look at 0, there's no bolded line there, so it's not B. So we're looking between C and D. Okay, look at D. I have here that the degree is 2 or more than the denominator from the top and the bottom, so that would be a neither. That's a possibility because there's not really one in the picture. It kind of looks like you could have one being diagonal. Okay, so let's look here. 3 and 2. This tells me I have an oblique. And that looks possible to me because if I'm looking at the graph, I kind of feel like the graph could follow a trend like this. Okay. All right, let's go ahead and factor this one down here. So I can take out an x out of the top. I'm left with x squared minus 4. That's the difference of 2 squares. So this would have an x minus 2, and an x plus 2. In the denominator, we're going to take out a 4 and an x. And we're left with x minus 3. So come over here, I got a 4 and an x, and I'm left with x minus 3. Those x's would cancel. So if I look and set the denominator equal to 0, I know that at 3, I have a vertical asymptote. Well, look at my picture. I have a vertical asymptote at 3. So my answer here is D. Okay. I'm just going to leave that up for a minute just in case you are copying stuff down at the same time that I'm working. Okay, question number 7. Determine whether x minus c is a factor of f. And they give you a big long equation, and then they give you c equals -9. So all you have to do is take your -9, plug it into your x's. If it equals 0, it's yes. If it doesn't equal 0, then it's no. So if you know what you're doing, this problem is one of the easier ones on the test. So plugging in -9. Don't change any of the signs or anything. Okay, and then this is when your calculator comes in handy. And you would type this in as one big string in the calculator. Okay, and then it gives me 0 as my answer. So since it is 0, the answer here is yes. And just as a little side note, any number but 0 would be no. We also did this same concept doing synthetic division, but I personally think that just plugging it into the x's is a lot faster and easier to do. Okay. Question number 8. Which polynomial below could have at most 3 zeros with possible rational zeros p over q equals plus and minus 1, plus and minus 1/2. So if you recall, it's been a while, but your p represents the last term and the q is the first term. It's the coefficient from the first term. Okay, so with that fact alone, I know that my p, look at the tops, is going to be 1. And I know that the coefficient, the bottom, if I look at the bottom there, that's a dead giveaway, but that is going to be a 2. Okay, so already I can tell this one is flip-flop, so it's not A. And if I look at C, it is flip-flopped, it's not C. So we're looking between B and D. Now, the most with 3 zeros, that fact there tells me that the degree is 3. If it said with at most 4 zeros, then the degree would be 4. So you're looking, there's the one with the 3, that's the 4th degree. So our answer there is D. Okay, question number 9. Find the zeros, and they give you a very long equation. So basically what you're going to have to do here is you have to factor this thing. So I've got 4 terms. I need to figure out what's in common in all 4 terms. I know I have an x squared is in common, so I'm going to take out an x squared. So 5 minus 2 would be x to the 3rd power. 4 minus 2 would be an x squared. 3 minus 2, that would be just an x. And of course, 2 minus 2 would just be your plain old 25. Okay, when you have 4 terms, you should factor by grouping. So we're going to put parentheses around the first 2 and around the last 2 terms. So we'll keep the x squared there. And then you look, what can I take out of this set? Well, I can take out an x squared again, and I'm left with x minus 5. Over here, you know these 2 sets have to match, but you can look, I can take out a 5, and I have that minus right there, so I'm going to bring down the minus and the 5, and I'm left with x minus 5. If you did this right, these 2 parentheses sets should always be the same. If they're not the same, you did something wrong. Okay, so we have our x squared here. And then if you recall, we put this and this together in one parenthesis set. So x squared minus 5. And then this comes down just one time. And you just ignore that one there. So that's x minus 5. Okay. Now, so for the multiplicities, you're looking at the exponents on the degrees of your exponents here, and you want to set each term, each piece equal to 0. So x squared equals 0, that's going to be x equals 0 because you would square root both sides. So I know I have 1 with 0, look at the degree, so 0 multiplicity 2. So I have a 0 and a multiplicity 2. Because that's a 2 on the exponent. So already I know it's not C and it's not D. Okay, 0 multiplicity 2, 0 multiplicity 2. I have to keep going. Okay, right here I've got x squared minus 5 equals 0. So add 5 to both sides. So x squared equals 5. Square root that. So I get x equals plus or minus the square root of 5. Okay, look at your degree. You need to pick the one outside the parentheses. So that would be a 1. So I would have plus or minus the square root of 5 multiplicity of 1. Okay, and I know that this has to be the answer because that forgot the negative of it. But let's go ahead and finish the last part. Set that equal to 0. Of course, we would add 5, so I get x equals 5. I know, look at the outside degree, it is 1. So 5 is a multiplicity with 1. So A is the answer for this one. Question number 10. Use the given 0 to find the remaining zeros of the function. So they give you a really big long equation and they tell you that the 0 is -1 plus I. Okay, so what you have to do here is you have to be very careful with the commas and the semicolons that might be in your answers because it's really easy to get bogged down and to click the wrong answer because you missed the comma. Okay, so with the zeros, all you do is change the sign in front of the I. So I know this has to be -1 minus I. Okay, that has to be another 0. So if I look, I know A can't be it because that says 1 minus I. B is a possibility. C is a possibility. And here's where it's easy to get cross-eyed. D is definitely not it. But it's really easy to pick E or to get the wrong answer because of the comma there. Your eyes don't want to read that comma, and it looks like that says -1 minus I, and you skip over the commas when you read. So you're going to have to really train yourself. It's not going to be that because that has a comma right there. So I know it's between B and C. So what you want to do is take your two answers off to the side, plug them into the X's and see which one gives you a 0. So we will take 13 here. So 13 to the 4th minus 12. 13 to the 3rd minus 13. 13 squared. 2 and a 13 plus a 26. Okay, you're going to plug that whole thing into the calculator. I would just plug it in as one big string. Okay, so 13 to the 4th power minus 12, 13 to the 3rd power minus 13, 13 to the 2nd power minus 2 times 13 plus 26. Okay, now since that gave me a 0, this is the answer we're going to pick. If it gave me a number other than 0, then I would check C. I don't even need to check C because I know that it's B. But you can clearly see she put the same thing on there, and the only thing she added in there is it'll either be a comma or a semicolon. So you have to really make sure you're reading, because for me it's hard for my eyes and I just want to automatically pick the wrong one. Okay, 11. Determine whether the graphs below is 1 to 1. So this has to pass a horizontal line test. Okay, so if you look and you have your pencil going horizontally down, it should only cross the graph one time. So if I look just even here, you can see I clearly passed twice, so this is a no. Okay, look on this graph, it's pretty evident I would clearly pass even just all of the spaces twice, so that's a no. If I look here and I pull down each time, I never pass the graph more than once. That one would be a yes. Question number 12. Find the inverse to the 1-to-1 function. F of x, where that is y, equals negative 8x minus 4. So what you do is you flip-flop for inverse, flip the x and the y, and you solve for y. So for the inverse, you flip x and y and solve for y. Okay, so instead of saying y equals, that's going to say x equals negative 8y minus 4. Okay, then we solve for y, so we're going to add 4 to both sides. So x plus 4 equals negative 8y. Divide every piece by negative 8. So I get y equals negative x over 8. And if you look at the 4 divided by 8, that would be a 1/2. So minus 1/2. Okay, so it looks like they didn't actually reduce that. They just kept it over one denominator. So coming out another way you could just do this is negative x minus 4 divided by just one plain old 8 on the bottom, which is what they ended up doing instead of separating and reducing. So the answer here is D. And the f to the negative 1, that just is notation for inverse. Okay, number 13, determine whether the function is exponential, linear, or neither. So if it is exponential, that means that you are multiplying or dividing by the same number. If it is linear, then you are adding or subtracting by the same number. Okay, so one important thing you want to do before you even determine anything, look in the X column, make sure there's no gaps. If there are gaps, you have to fill in the gaps. So look for no gaps. Then you want to look in the Y column and see if you can't figure out a pattern. So 1/18 to 1/6 to 1/2 to 3/2 to 9/2 to 27 over 2. So we got to figure out what's going on there. Okay, so one thing, I could use the fraction button, that would help. Maybe try to divide the two numbers. Okay, so that gives me a 1/3. Okay, so I wonder what would happen if I did 1/18 times 3. So that gives me 1/6. So I just did the opposite there. Times 1/6 by 3. That gives me 1/2. Times that by 3. I get the 1 and 1/2. So what we're doing is we are multiplying by 3 each time. This is exponential. Okay. All right, so the next one, look over here, there are no gaps. Negative 16, 11, negative 6, negative 1, 4, and 9. Well, to get from negative 16 to 11, we are adding 5 each time. So since we are adding 5, this is linear. Okay. All right, number 14, what is the domain and range of the following function? I would probably recommend just graphing these. If you know the way that the graphs shift and you know the parent function of what the graph looks like, this should not be too hard of a graph to draw. So if you look at 4 to the x power, most of these exponent graphs look very similar. So go into our y equals, we'll just graph 4 to the x power. To the x power. And most of these exponent graphs look the exact same. They cut through 1 on there. So you can see on here, they cut through 1. They always start this way and then they go up. So you need to remember that parent function on here. So the -2 means that it's going to shift down 2. So let's look at our graph here. So instead of it cutting through at 1, it's going to shift down 2. So 1, 2, it's going to cross at -1. So it's going to come and cross up. And there would be your asymptote would be right here. Okay, so your domain, if I look at my graph, it would be -infinity to infinity. The range is what's going to change. So since I have an asymptote here at -2, it's going to be -2 to positive infinity. And the -2 gets a parenthesis because that's a dotted line there and it will never cross there. Okay, now if I look at this one, if I just looked at the 1/3 to the x, we'll ignore the negative and the +1 for a minute. It should look the same as the other graph. So alpha y equals, enter button gives you your fractions. So 1/3 to, I always want to do that, to the x. So the graph looks this way because the fractions, that's the way the parent graph looks like when a is a fraction right here in the front. So the negative is going to flip the graph over down, and then the +1 will shift the graph up 1. So if I look here, the graph is, instead of going that way, it's going to start here at the bottom. And normally, if it would just be the negative, okay, so let's do this in a couple pieces before we get the official graph at the end. So if I were to just graph the -1/3 to the x without having the 1, it would look like that. Okay, so you can see right here, my calculator's starting to turn off, that it crosses the y-axis at 0, 1, and then if I add in the negative in the front, you can see it's going to cross at -1 right there. Okay, so that is that. Now when we add in the 1, it's going to shift the graph up 1 space. So now it's going to cut through 0, 0. And now your asymptote will be here. So this is what happens when you have your -1/3 and you're adding 1 to it. So I would probably graph these in pieces before you graph the official one. So we're looking at this graph. The domain is -infinity to infinity. And the range here would be negative infinity up to positive 1. And we won't include 1 because that's a horizontal asymptote. Alright, number 15, solve the equation 6 to the negative m equals 36. So we want to get the bases the same, so we can use that formula from the front that said if the bases were the same, then you could just set the exponents equal to each other. So if you look here, 6 squared would give me 36. So I know that this is 6 to the second power. So we can set this equal to this. So negative m equals 2. Divide by negative 1. So m equals negative 2. Okay, next problem, exact same concept. It just looks more difficult, but it is going to be the exact same thing. So I need to figure out 5 to the what exponent gives me 625. Well, obviously it's not 5 squared because that would be 25. So let's go 5 to the third. And I would just, you know, it's not going to be too big of a number. So 5 to the fourth is 625. So this is 5 to the 2 minus 2x equals 5 to the fourth. So we'll set the exponents equal. So 2 minus 2x equals 4, minus 2 on both sides. So negative 2x equals 2. Divide by negative 2, and x equals negative 1. Okay, 16. Information is given about a complex polynomial f of x whose coefficients are real numbers. Find the remaining zeros for f. So we have that the 0 is negative 3, and then we have a 3 plus 2i. So anytime you see an I, you know you need the opposite sign. So I know that a 0 is going to be 3 minus 2i. Look at your degree. Your degree is 3. So that tells you the total number of zeros. So I know that there are 3 zeros. So 1, 2, and there's the third one. Just make sure you read there, because I can guarantee you one of the answers would be 3 comma negative 2i, and you don't want to pick that one. Alright, 17. Find the x and y intercepts of the rational function. Y-intercept is always my favorite, so I just start with it. All you do is plug zeros into your x's. Alright, which honestly you could do that without writing all this out. So this is 0 minus 2, so this is negative 2 on the top. This is 0 plus a 6. Reduce your fraction, we get negative 1/3. So 0 comma negative 1/3. Be careful when you're reading the answers, because I can pretty much promise you that negative 1/3 comma 0 would be an answer choice and it would be the wrong one. Alright, X-Intercept. So for the X-Intercept you want to factor and reduce and stuff. But you set 0 equal to y, and then you're going to solve. So we set 0 equal to y. Now I'm going to get rid of the 3x plus 6 by timesing both sides by it. And honestly, when you get really good, you can just skip this step, because you'll always know those will cancel. 0 times that is just 0. So it's really always just setting the numerator equal to 0 and solving. So we need to factor the numerator here. So the only thing that times to 2 is 2 and 1. So minus sign means the signs are different. The bigger number gets the negative. The other one's going to be positive. Set each piece equal to 0. So I know that x is 2. And here I know x is negative 1. So that would be -1, 0, and 2, 0. And of course, I can pretty much guarantee you that the opposites of these with zeros and the 2 and the -1 would be flip-flopped, and of course that would be wrong answer choices also. 18. List the potential rational zeros of the following polynomial. So this is the P and the Q thing. You'll know pretty clearly that it's the P and the Q thing because of the answer choices. So you got your P and your Q. Your P is the last number, so that would be 10. You can ignore the signs, it doesn't matter. Q is their first number, that's a 3. So then you list all the numbers starting with 1 and the number you have, and list all the numbers that multiply to 10. So 1 times 10, 2 times 5, and that's it. Then we're going to list all the numbers that multiply to 3, so 1 and 3. Then your answer is your P over Q, so it's 1 divided by 1, so that's 1. 2 divided by 1, that's 2. 5 over 1, that's 5. 10 over 1, that's 10. Then we do 1 over 3, so that's 1/3. 2 over 3 is 2/3. 5 over 3 is 5/3. 10 over 3. And this is your answer that you would pick. All right, number 19, which of the following rational functions could have this graph? Okay, well the good news is everything is already simplified for you, so that's good. Now I would probably start by looking with a horizontal and oblique. When you do that, you're not just looking at this first term here and saying it's 1 over 1. You have to actually kind of distribute here. So this is actually looking at x over x squared. So that's going to tell me there's a horizontal at y equals 0. If I look here, it's hard to see, but my horizontal is right here, and that's at 1. Okay, so I know it's not A. All right, x times x, that would be an x squared on the top. X times x on the bottom would be an x squared. So this would be horizontal at y equals 1. That's a possibility. X times x times x. So this would be an x to the third on the top. X times x would be an x squared. So the top is one more than the bottom. That's an oblique. And you can never have horizontal and oblique on the same diagram. So if you see a horizontal, you know you do not have an oblique. So it's not C. It's either one or the other, or neither. But you can't have both. All right, x times x, that's x squared. On the bottom, I forgot the parenthesis, but it's x times x, so that's another x squared. So this is another horizontal. You take the coefficients in the front, so horizontal at y equals 1. So we're looking between B and C now. So now we need to go off of the vertical asymptotes. If I look at my vertical, I know I have one here at 1 and 1. I'm going to write it out because it's kind of hard to see. So I know I have a vertical asymptote at 1, and then I have another vertical asymptote at -3. So you want to set these denominators equal to 0. So for this one, x minus 3 equals 0, so x would equal 3. So I already know it's not B, it has to be D. All right, question number 20. If the following function defines a one-to-one function, find the inverse. Okay, so what you want to do is you want to look at the y numbers and make sure they're not the same. So I have a -1, a 0, and a -8. So we are good. If I had -1 printed twice or a 0 printed twice in the y coordinate spot, then this would be no, it's not 1-to-1. So yes, this is 1-to-1. Because we don't have two numbers of the same y's. We don't have 2 of the same y numbers. Okay, so since this is a yes, now we need to list the inverse. And if you remember, inverse just means you're flip-flopping the x and the y numbers. So you just reverse these. So your inverse, so we flip-flop those, so it'll be -1 and 12. Flip-flop these, so 0 and 9. I guess they're going to have commas in between these. Flip-flop the last one, -8 and -13. Okay, so that is the study guide in a nutshell. Remember that you have 20 multiple choice questions, 5 points apiece. Please, 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 with all of your heart, memorize and understand page 355, blue box. You have to have that memorized. If you do not, and you look just through this real quickly, you would miss 1 question for number 2. 2 questions for number 5. So that's 2 questions. 3 questions for number 6. I know there was definitely another one on there. 4 questions right there. So that was just on this study guide. 4 questions with just 1 concept. It could be even more, because every time you open up the test, there is multiple versions. So please make sure you know that blue box. All right, have a good day.